Hello everyone, my name is Alex. I'm here live from Sheffield, and I'm happy to be presenting this paper together with Raphaël, Sylvain and Damián. There I am, on TidalVortex Zero. So this is a port of TidalCycles. If you don't know it, it's a live coding environment based on the concept of algorithmic pattern with a functional reactive programming model inspired by functional reactive programming, but also Indian classical music and things like that. So this project was initiated from something I did last year, which was rewrite Tidal in Haskell. So it's written in Haskell and I rewrote it again in Haskell. I like to do this every now and then, but this time I decided to try and do it while live streaming and without looking at the current source code base. So this was an opportunity to try and reconstruct Tidal from memory while talking aloud to a stream audience, and managed to sort of reconstruct quite a large part of the underlying type structure and so on for Tidal during those 2 hours. And this proved to be a nice base for porting Tidal to other languages because it was nice and clean. I'd sort of understood it because it's possible to write code without fully understanding what it is, especially when with something like Tidal, which has been developed since 2009 over a long period of time through various processes. Anyway, so this is what Tidal's inner pattern representation looks like. Basically, it's based on events. Probably most of you won't understand Haskell code, but basically a pattern is a function from time to events. So similar to sound synthesis, but also supporting discrete events. So everything is a function. There's also higher order stuff for combining these patterns together, which I'll talk about a little bit with some code examples. There was a bit of fear and uncertainty when I first mooted the idea of porting Tidal from Haskell to Python. There's Haskell's a functional programming language with lots of stuff to support strongly typed structures and some fairly advanced things like partial application, type inference, and type structures like applicative and monad. And Python doesn't have a lot of this. I mean, it does really, and actually it was all fine. So that's the message: is that it's fine to port stuff from a strongly typed language to a multi-paradigm one. And Python has things like func tools, which supports partial application, but also stuff like applicative and monad. It's actually pretty simple when you get down to it. Just a few functions to define. There were some problems like error checking is a bit harder, but maybe errors aren't so important for live coding. So this is what Vortex looks like at the moment. It hasn't actually had much development since I wrote this paper with the others. It's sort of on the back burner a little bit, but it's possible to write code with it. It looks like this, which is fairly easy mapping from Tidal to Vortex, if you're familiar with Tidal. It doesn't have mini notation for describing polymetric structures that Tidal has. But aside from that, it's pretty complete. Tidal doesn't make sound itself, neither does Vortex. It sends OSC to the Super Synth, which is implemented in Super Collider. So as I say, Vortex isn't actively developed at the moment. It's sort of waiting for someone to pick it up. I'll probably pick it up again in the future when I need to do something with Python. But Strudel followed on from it, and that is really active and pretty feature complete at this point, and has some features which Tidal doesn't, which are feeding back into Tidal. So yeah, it's spawned another project, Strudel. So this is an example of Tidal code, just to play a bass drum, a snare drum, and a clap. In the structure, this is what it looks like in Vortex. As I say, Vortex hasn't got the mini notations, so you have to spell it out a bit more. The structure using functions. Strudel does have the mini notations, so that looks pretty close to the Haskell version, but Strudel being the JavaScript version. In terms of composing different kinds of patterns together, in Vortex, it overloads this bit shift operator, and Strudel, it uses a object method to do that. But yeah, still looks fairly the same. I could have used mini notation here as well. I don't know why I didn't. So that's fine. For pattern transformations, like reverse, we'll reverse the pattern. You can either, in both Vortex and Strudel, you can either call that as a method or as a top-level function. You can also add patterns together. That's one of the nice things about Tidal. Even if this has 3 events per cycle and this has 2, you can just add them together, and then it'll align them, and you end up splitting the 2 in half between the 4 and 5, and end up with 4 events. And you can do that in Vortex and Strudel because the underlying pattern representation is the same. It will work exactly the same, hopefully. In Vortex, you can overload the plus operator, so it looks pretty similar. In Strudel, you can't do that in JavaScript. You can't overload functions for some reason, rather infix functions operators. So everything is either a method, or you can use that as a top-level function as well. Higher order transformations, obviously very important. As I say, partial application works fine. So this rev doesn't have an operator, a parameter, so it will return, it'll just be, actually in this case, it's not partial application, it's just a function, isn't it? It's being passed. But here the fast isn't giving a pattern to work on, so it'll return the function that will. And so, yeah, it looks pretty equivalent. You end up tagging on functions to the end rather than the start if you're using the method, which is what you generally tend to do with both Vortex and Strudel. It's a bit cleaner because you don't have the dollar for separating parameters from functions. It's just easier to tag them onto the end. So it looks like that. But then everything in Tidal is a pattern, or these values are patterns, and it's the same in Vortex and Strudel. So you can replace those numbers with patterns if you want, like this. I'm not sure what this would actually sound like. This is just like a trivial example just to demonstrate the syntax. But you can see that all those numbers have been replaced with patterns. This is what all the stuff I showed briefly earlier around applicative and monads allow you to do, is just combine together patterns on different levels. So yeah, that's about it. If I can find my notes, which, oh yeah, here we go, in behind there. So yeah, I'll be very happy to answer questions. I think I should be able to see them in the chat in Deck 10, so please do ask questions there. While I conclude with a few thoughts. So rewriting software really helps you understand what you've made, makes it clearer, and allows the opportunity for explaining it to others. In fact, Strudel and Vortex aren't the only ports. There's also a port to Kotlin by, I think, Andrea, and there are other ports on the way, perhaps. it's also, let's see what else I wrote. Oh yeah, so although Strudel's really active at the moment, it doesn't mean that Tidal is abandoned. I think Tidal and Haskell are still the best language for me to explore developing new ideas, just because all the functional programming stuff is really supportive to exploring representations, in my experience. And indeed, I'm hosting a Google Summer of Code project exploring Konakol, South Indian Carnatic vocal percussion, with a Google Summer of Code student, Aravind Mohandas, which will hopefully bring the amazing structures of Konakol to Tidal. And then that will be a springboard onto these other systems. One particularly exciting thing about all this is that now that's kind of the core of Tidal is ported to these other languages. It means that the mini notation is easily available to other live coding systems like Jibber and Hydra. I think this is really nice. Just because it allows a kind of common language for describing rhythmic and metric structure, which different musicians and visualists can share, not to necessarily play the same rhythms, but share the same underlying meters and sort of transform that meter in different ways, so that we can sort of respond to each other in interesting algorithmic ways. So yeah, that's about all I've got. So I'll just check the chat to see if there's any questions, if I can find that window.
So Alex, can you hear me?
I've got, so
yes,
I'll just check the chat to see if there's any
Alex?
questions. If I can find that window.
Alex, can you hear me?
I can. There's just a bit of a delay, of course, but please, questions would be great. Hello, Giuseppe? I can see a question in the chat from Giuseppe. Is there video material of performance of the system? I did do a performance. I don't think it was actually properly recorded. Had some problems with the audio. So the answer to that is no, not at the moment. But you can install it. It's actually a lot easier to install than the Haskell Tidal for various reasons. So you can just try it out yourself. Strudel is more developed, as I say. So if you go to strudel.tidalcycles.org, there's loads of demos there that you can randomly step through. Okay, so I guess there aren't more questions. There's a few links to the software and also the paper. There's a lot more details in the paper about various things, so have a look in there. So I'll wait a bit longer to see if there's any more questions that pop up. Otherwise, oh, I think there's another one coming through. How important was the Twitch streaming for the community aspect? Asked Giuseppe. For me, it was just felt really nice. I did manage to talk throughout, which I was quite surprised by. I'm not sure if I'd have actually done it without people there encouraging me along. And I think as far as what people said in the chat, people did learn a lot about how the inner representation of Tidal works by participating in that. So I'm hoping that kind of thing will mean that there will be more contributors to Tidal, because although it's now ported to JavaScript and Python, which are very popular languages, it still brings with it all the strange functional representations from Haskell. So it might still be a bit difficult to understand. That's not too much a barrier. You can just work on the graphical interface side and the sound synthesis side, not the inner representation. But yeah, for me, it was really important. I'm not sure how important it was for the people watching. You'd have to ask them, but as far as I could tell, they were enjoying it. The back end of Strudel, asked Magno, it's got various things. You can use MIDI. I've used it with Web Serial to control a robot. Yes, there's an OSC bridge to use it with Super Collider and Super Dirt. But actually, there's a lot of work going on the synthesis in the browser, and that's sounding really nice, both using WebDirt, which is made by David Ogborn, and some sort of other native JavaScript stuff. Actually, Strudel is mostly developed by Felix. What's his surname? I can't remember. But Felix is doing loads of work on Strudel, has actually committed more lines of code than me. So full respect to him. Felix Roos, that's it. Okay, I think my time is now up. So thanks, everyone, and take care.